Okay, so in this section we're going to learn about patterns in oxyanion nomenclatures. Okay, when there are two oxyanions involving the same element, the one with the fewer oxygens end in "ite", the one with the more oxygen ends in "ate". So in these oxyanions means it has oxygen and also has another element. So this is oxygen with nitrogen, oxygen with nitrogen. There are two oxygens here, three oxygens here, and they are anions. So the one with the lower oxygens ends in "ite", nitride. One with higher oxygen content ends in "ate", nitrate. Okay, and then this is SO32 minus, SO42 minus. So this one is called sulfide, SO32 minus sulfide, SO42 minus ends in sulfate, ide 8. Okay. Naming oxoanions. Sometimes we do have compounds that have oxoanions that can have 4 different amounts of oxygens in it. Okay, if there are 4 different amounts, normally this happens with halogens. Halogens are the group that we find elements in group 7. Okay, halogens. For example, chlorine. Let's take chlorine. Chlorine, if you have 4 oxygens in chlorine, we call it as perchlorate. So if you have chlorine can have 4 different amounts of oxygens. So these are the 4 different amounts. 1, 2, 3, 4. Right? So the top one has the highest number of oxygen. So we're going to put a prefix per, and then the root would be chlor, and suffix is ate. So we call this as per is the prefix. Root is chlor, CHL, chlor. Okay, and then the suffix is ate. So the name of that is going to be perchlorate. And if instead of chlorine we have iodine, we would say periodate. Instead of chlorine, if you have bromine, we would say perbromate, like that. And then that is the highest amount. And then the next one, you don't put any prefix, you just put the root name, which is chlor. And then you just gonna write chlorate. And then the next one with less number of oxygens, ClO2, would be naming as chlorite. And then the lowest number of oxygen, you put the prefix hypochlorite. CHLO, chlorite. Hypochlorite. Perchlorate, chlorate, chlorite, hypochlorite. Okay, and instead of chlorine, if you have bromine, there would be perbromate, bromate, bromide, hypobromide. If you have iodine, instead of chlorine, it would be periodate, iodate, iodide, hypoiodite. Excuse me. That's how you name when you have 4 different amounts of oxygens. Okay. Patterns in oxyanion nomenclature. So if you have a simple anion, that simple anions we find from the periodic table, just like our chlorine would be chloride, just chloride. Bromine would be Br minus, bromide. Okay, that's a simple anion. But what we are talking about is the oxyanion, right? That one right there. So for the oxyanion, if you start from here, this is chlorate. Common or representative oxyanion we can consider as chlorate. ClO3 minus. And then if you have more oxygen, one more oxygen, you put the prefix perchlorate. One less oxygen, just chloride, and another oxygen less, that would be hypochlorite. The one with the second fewest oxygen ends in ite. ClO2 therefore is chloride. The one with the second most oxygen ends in ate, chlorate. The one with the fewest oxygen has the prefix hypochlorite, ClO minus, and then one with the most oxygen has the prefix per and ends in ate, perchlorate. It's the same thing that we talked about in the previous slide. This here it is a little bit more elaborate. And so those are the anions. And these anions can come from an acid. If you put hydrogen, that would become an acid. Now for chloride anion, you add H plus ion. We call that acid as hydrochloric acid. It's a binary acid, meaning there are two elements, hydrogen and chlorine. It's a binary acid, hydrochloric acid. If it is bromide, you add H plus, that would be hydrobromic acid. If the anion in the acid ends in ide, change the end into ic acid and add the prefix hydro. HCl would be hydrochloric acid. HBr would be hydrobromic acid. HI would be hydroiodic acid. These are binary acids. But then if you have those oxyacids, you see here chlorate and perchlorate, you add H plus to make it an acid. If the anion ends in ate, your acid will end in ic. Chlorate will become chloric, HClO3. Perchlorate will become perchloric acid. If the anion ends in ite, chloride, hypochlorite, you add H plus and then it will end as us acid. Chlorous acid, hypochlorous acid. Okay. If the anion ends in ite, change the end into us acid. Hypochlorous acid, chlorous acid. If the anion ends in ate, change the ending to ic acid. Chloric acid, perchloric acid. Same thing, chlorine can be changed to bromine or iodine, and then you would change it to hypobromous acid. Bromous acid. Bromic acid, perbromic acid. And if it is iodine, you would say hypoiodous acid. Iodous acid, iodic acid, periodic acid. Okay. The same thing is written here. Binary acid solutions form when certain gaseous compounds dissolve in water, like your hydrochloric acid. For example, when gaseous hydrogen chloride dissolve in water, it forms a solution called hydrochloric acid. So notice we put this hydro part for the binary acid, hydrochloric acid. Okay. Prefix hydro, anion, nonmetal, root, and then the suffix ic, the word acid, hydrochloric acid. Oxoacid, meaning if the acid has oxygen, names are similar to those of the oxoanions except for two suffix changes. Ate in the anion become ic, ite in the anion become us. Oxoanion prefixes hypo and per are retained. Thus, BrO4 minus bromate, perbromate, and HbRO4 is perbromic acid. iO2 minus is iodide and HiO2 is iodous acid. Okay. Okay, problem. Determine names and formulas of anions and acids. Name the following anions and give the name and formula of the acid derived from each. Now, what is the name of this ion Br minus? It is bromide. So for bromide, you add H plus and become HBr. When you have hydrogen and bromine, you would call this as hydrobromic acid. Okay, that would be hydrobromic acid. And then you add H plus to this one. What is the name of this ion? It has 3 oxygens. That is iodate. If you had 4 oxygens, that would be periodate. So this is iodate. Remember, 8 ends in ic. So it would become HiO3, and then iodate will become iodic acid. And then this is cyanide. Cyanide with H plus is going to form HCN. We call it as hydrocyanic acid. And HSO4 minus, hydrogen sulfate, you add H plus, that would become H2SO4, that is sulfuric acid. Hydrobromic acid, iodic acid, hydrocyanic acid, and sulfuric acid. Okay, that is the naming of oxoanions and the acid derived from those oxoanions. So we'll conclude this section here, and then we can start talking about the covalent compounds, how to name them in the next session.